Hey there, Algebra 1 students. Today I want to talk to you about linear, exponential, and quadratic functions. Basically, it's all about determining whether or not a set of data fits one of these particular models better than the other. So let's just refresh our memories here. A linear function has an equation of the form y equals mx plus b. That's your slope-intercept form. And it's a line, right? Linear is a line. It looks like that. Or it could have a negative slope, right? Here you've got an exponential function, y equals a times b to the x power. And here it is an exponential growth function. You guys remember exponential growth, right? That's what I thought. And quadratic functions, what we've been working on lately. Y equals ax squared plus bx plus c. The shape is a parabola. It has a portion where it is decreasing and then it is increasing, or perhaps it's increasing and then decreasing. But either way, it has that distinctive parabola shape. So we can use patterns between consecutive data points to determine which type of function models the data, right? The differences of consecutive y values are called first differences, and the differences of consecutive first differences are called second differences. So in a linear function, the first differences are constant. They're all the same. In an exponential function, the consecutive y values have a common ratio, and in a quadratic function, the second differences are constant. In all cases, the differences of consecutive x values need to be constant, right? The x values need to be constant. And so over the same interval, the average rate of change of a function increasing quadratically eventually exceeds the average rate of change of a function increasing linearly. So the value of the quadratic function eventually exceeds the value of the linear function, right? The quadratic function starts to change faster. And, over the same interval, the average rate of change of a function increasing exponentially eventually exceeds the average rate of change of a function increasing linearly or quadratically. So the value of the exponential function exceeds the value of the linear or quadratic function. Okay, so let's put this into practice. All right. In these exercises, we have a bunch of data points, and we need to determine whether it's linear, exponential, or quadratic function. And let's see. Here, -3, 2 would be that point right there. -2, 4 would be here. -4, 4 is there. Right, -1, 8 would be here. And -5, 8 would be there. And if I'm looking at that, that looks like it has the shape of a parabola. And so I would say that this is quadratic, right? What about here? Number 2. I have my x-axis and my y-axis drawn. So -3, 1 would be there. -2, 2. -1, 4. 0, 8. 2, 14 would be like way over there. And so if I were to connect those dots, it would look sort of like that. And it looks like it's evening out down here. And so I would say that this one is an exponential. Exponential. There we go. Okay. let's take a look at number 4 real quick. You've got 2, -4, so positive 2, down 4. Okay, 0, -2 is there. -2, 0 is here. -4, 2 is there. And -6, 4 is somewhere over there. If I connect the dots, I get something that looks like that. And that to me is linear, right? That's a line. Okay, suppose though they give you a data set and they don't tell you to graph it. They just want you to determine whether or not it is, you know, a thing. Like, what is it? Just by looking at it. So we're going to take the first differences. We're going to take the y values. First, we're going to notice that there's only a difference of 1 between all of our x values. And then I'm going to take the second y value and subtract the first one. So 4 minus 7 is -3. And 1 minus 4 is -3. And -2 minus 1 is -3. And -5 minus -2 is -3. And so because those first differences are all the same, this is a linear equation, right? And number 6, the differences aren't quite the same, right? 2 minus 6 is -4. 0 minus 2 is -2. 2 minus 0 is 2. 6 minus 2 is 4, right? And then if we took the next differences, -2 minus -4 is 2. 2 minus -2 is 4. 4 minus 2 is 2. Those are not the same exactly, but for most quadratics it should be. But if I plotted them, it looks like that. And so we would say that this looks like a quadratic. And that's where we're going to stop today. I hope that this makes sense. I hope you're doing well. We'll see you next time.